Hi everyone, welcome to this GCSE Higher Revision video. There's 85 days to go into your GCSE Maths exam, and today we're going to be focusing on reverse percentages. Now, reverse percentages is one of those topics that comes up quite a lot in the GCSE Maths paper, so it's important you know how to do it. Now, I was going to do a bit of a joke today where I wrote this backwards, but I decided not to, reverse percentages. But if you do have the revision cards, card number 57 is the reverse percentages revision card, and it goes through an example on James buying a car and then he sold it for a certain amount of money, and that was 15% less than what he bought it for. How much did he pay for it to begin with? So that's a typical reverse percentages question. Now, in terms of reverse percentages, we don't necessarily know the context that's going to be used in the GCSE paper. So what I would say is, in this video, I'm going to go through some examples. There'll be some for you to try, but I would highly recommend in this particular video to try the practice questions because it'll get you used to some of the reverse percentages context that could come up. So let's get started.
Okay, so in this video, we're going to look at reverse percentages. So that's whenever we know what the value is after something's been increased or decreased by a percentage, and we have to go back and find the original. Now, there's two different approaches which I usually use for these questions. One is where we write down what percentage we've now got and then work out 1% and then find 100%. Or another approach is to use the multiplier. And obviously, previously, we've looked at compound interest where we've talked about multipliers. So in this video, I'm going to talk about both approaches. So I'm going to do each question. There's 4 questions in this video, and I'm going to talk about each one in 2 different approaches. Okay, so let's have a look at our first question. So first question says, Rebecca's given a 35% pay rise. Fantastic. And she's now paid £13.77 per hour. And the question said, what was Rebecca's pay before the pay rise? So we now know what her pay is, but we want to find out what it was before it went up by 35%. Okay, so it's gone up by 35%. So that means we've now got 135%, and that's now equal to £13.77, so £13.77. Now what we're going to do is we're going to find what 1% is, and then we can then go from 1% to then find 100%, and 100% would have been what her pay was before her pay rise. So let's get what 1% is. So to get from 135% to 1%, we're going to divide by 135, and likewise we're going to divide by 135. So 1% is, well, dividing 135 by 135, we get 1%, and now we need to take the £13.77 and divide that by 135, and that's equal to £0.102. So we now know what 1% is, but we don't want to know 1%, we want to know 100%. So if we know what 1% is, we can multiply it by 100 to find 100%. So we just need to multiply by 100. So 1% multiplied by 100 is 100%. And then if we take the £0.102 and we multiply that by 100, so multiply by 100, we get that's equal to £10.20. So that means that Rebecca was paid £10.20 to begin with. And that's it. So Rebecca's pay before the pay rise was £10.20, and that's it. So in this question, we know that she was given a 35% pay rise, so that's 135%, and then we know what that's equal to, £13.77. We then divided both of those values by 135, so we then find that 1% was 0.102. We then, if we know 1%, we can multiply by 100 to find 100%, and that's 100% is £10.20. So that's how much Rebecca was paid before the pay rise, and that's it. So that's one possible approach we could use for reverse percentages. Another approach is the following. This is Rebecca's pay to begin with, and then she's given a 35% pay rise. So that means that we have multiplied the amount of money she had to begin with by the multiplier. Now, if something goes up by 35%, and then you then have 135%. So if you multiply by 1.35, and watch the video on compound interest, I talk about multipliers quite a lot in that video. If you take her pay to begin with and multiply by 1.35, it then gives us an answer of £13.77. So to work out this value, the amount Rebecca was paid before the pay rise, we just need to go backwards. So we just need to divide by 1.35. So if we divide by 1.35, or divide by what the multiplier would have been, we can find out how much her pay was before the pay rise. So if we do £13.77 divided by 1.35, that's equal to £10.20. So her pay before the pay rise was £10.20, and that's it. So that's another way you can approach reverse percentages, is to divide by the multiplier. So obviously you'd know what the multiplier is to give her 35% pay rise, that would be 1.35. So you could just divide by 1.35, and that'll tell you Rebecca's pay before the pay rise. Now you can use either one of those 2 approaches. Sometimes I do find that for non-calculator questions, that first approach, the writing down that so much percentage such and such, finding 1%, then find 100%, can be quite useful for non-calculator questions, because here in this case we were dividing by 1.35, and that might be a bit tricky. So have a look at the question and decide which approach might be best for you. Okay, so let's have a look at a question now for you to try yourself. And in terms of this question, let's have a read of it first of all. So the population of Sandcliffe has decreased by 2% over the past year. And the population of Sandcliffe this year is 8,036. Calculate the population of Sandcliffe last year. So this is a reverse percentages question, and I know that because it's calculate the population of Sandcliffe last year, so we're going backwards to find out what it was before it went down by 2%. So that means it's reverse percentages, so we're trying to find that original population. So in this question, you can use either one of those two approaches we looked at previously. Feel free to press pause now to try the question yourself. So one approach would be, well, if we've decreased by 2%, we're left with 98%. So 98% is 8,036. So 98% is 8,036. So we want to find what 100% is. So let's find 1% to begin with. So to find 1%, we're going to divide by 98. So we're going to divide by 98 and we're going to divide by 98. So 8,036 divided by 98 is equal to 82. So we've got what 1% is. Now we want to find 100%. So we just need to multiply by 100 and multiply by 100. And if we do 1% times 100, that's 100%. That's what we want. That's the population of Sandcliffe originally, so last year. And 82 times 100 is 8,200. So that means the population of Sandcliffe last year was 8,200. And that's it. So that's one approach. Another approach would have been to use our multipliers. Well, the population of Sandcliffe last year, well, we decreased that by 2%. So the multiplier would have been, well, we would have multiplied by 0.98. To decrease something by 2%, you multiply by 0.98. And that gave us an answer of 8,036. So if we want to go backwards, we're going to divide by the multiplier. We're going to divide by 0.98. And if we take our 8,036 and we divide by 0.98, that's equal to 8,200. And that's it. So either one of those two approaches could work. That's it. Okay, let's have a look at our next question. So our next question, this is a non-calculator question. So the question says, a box contains red and yellow marbles, and 30% of the marbles in the box are yellow. And there's 60 yellow marbles in the box. Work out the total number of marbles in the box. Okay, so let's have a look at this question. We're going to try it in two different approaches. And remember, it is a non-calculator question. Now in this question, we're told that 30% of the marbles in the box are yellow. And we're also told there's 60 yellow marbles. So that means that 30% is 60. Because we know that 30% of the marbles are yellow and there's 60 yellow marbles in the box. So unlike the ones previously where it's gone up or down, this time we're just told what 30% is. So 30% is 60. So now let's find 1%. So to find 1%, we're going to divide by 30 and divide by 30. So divide by 30 and divide by 30. 30% divided by 30 would be 1%. And 60 divided by 30 is 2. So we've got 1% is 2. Now we want to find 100%. So we're now going to multiply by 100 and we're going to multiply by 100. 1% times 100 would be 100%, and then 2 times 100 would be equal to 200, and that's it. So that means there's 200 marbles in the box. And let's just check that. If we had 200 marbles in the box and we worked out 30% of it, so let's divide by 10 to begin with, that's 20. And then if 10% is 20, that means the 30% would be 60, and that's 60 yellow marbles. So that's fantastic, we've got it right. So there's 200 marbles in the box. So that's one approach, and if you got that right, well done. Okay, let's have a look at our second approach. So in this question, we're told that 30% of the marbles in the box are yellow, and there's 60 yellow marbles in the box. So that means that if we knew the total number of marbles in the box, let's just say this number, and if we worked out what 30% of it was, we get an answer of 60. So that means that if we multiplied by 0.3, if you multiply by 0.3, it gives you 30% of something. And if we multiply by 0.3, the answer would be 60, because that's what 30% is. 30% of the number of marbles in the box are yellow, and that's equal to 60. So if we want to go backwards and find out the total number of marbles in the box, then we need to go backwards, which would be to divide by 0.3. So we just need to do 60 divided by 0.3. So to do 60 divided by 0.3, what we would do is we times both of these numbers by 10, so we get 600 divided by 3, and that'll be the same answer. And this is to show you why. If you had 10 divided by 2, that's equal to 5, and then you do 100 divided by 20, that's also equal to 5. So if you multiply both the number you're dividing and the number you're dividing by, both by 10 or 100 and so on, you get the same answer. So if we do 600 divided by 3, that's equal to 200. So that means that 60 divided by 0.3 would also be equal to 200. So that means there must have been 200 marbles in the box to begin with. Now in this question, I probably would have used this approach, but you could use either one of those approaches. I tend to use the multipliers when I'm dealing with calculator questions, and that's it. Okay, let's have a look at another question. So this is our last question, and this is one that I want you to try yourself as well. So the question says, the number of visitors to a museum increased by 12.5% between 2022 and 2023. And the number of visitors in 2023 was 39,375. And the question says to work out the number of visitors in 2022. So feel free to pause the video now and to try this question. Okay, so I'm going to do this question now, and I'm going to use both approaches. So we're told the number of visitors in 2023 was 39,375, and we want to find out what it was originally before it was increased by 12.5%. So we know it's a reverse percentages question because we're trying to find the original. So what we're going to do is we're going to say, well, if we had 100% to begin with and it increases by 12.5%, that would be 112.5%. And that is equal to 39,375. And then if we divide both of these by 112.5 and divide by 112.5, that'll tell us 1%. So we'll get that 1% is equal to, and if we do 39,375 divided by 112.5, that's equal to 350. Fantastic. So we now know 1%, so we then times by 100 and times by 100. We're then going to find out what 100% is. So 100% is equal to 350 multiplied by 100 would be 35,000. That means the museum had 35,000 visitors in 2022, and that's it. Okay, so that's one approach. Another approach would be to use our multipliers, and I'm just going to move all this over to one side. Okay, so that was our first approach. Now let's look at our second approach using multipliers. Okay, so we're trying to find the number of visitors in 2022. So there was a certain amount of visitors in 2022, and then it was increased by 12.5%. So as a multiplier, that would be multiplied by 1.125. And then that gives us an answer of 39,375 visitors. So if we want to go backwards and work out how many visitors there were in 2022, we need to divide by the multiplier. So we're going to divide by 1.125. And if we do 39,375 divided by 1.125, that's equal to 35,000. So if you just divide by the multiplier, we get that's equal to 35,000 as well. And if you got that right, well done. And that's it.
And that's it. So in this video, we've looked at how to solve reverse percentages questions. I highly recommend you do the practice questions on this topic just because there's a range of different contexts that can come up, and I'd highly recommend you have a look at those. So I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Also, mention it to some friends and your teachers and so on, just to make sure that they can maybe benefit from it as well. So I really hope you're finding these 100 days to go's videos useful. And today's been 85, so I'll see you tomorrow at 3 o'clock for 84 days to go into your GCSE Maths exam. So good luck.